Okay, I think I can start. Since we have the recording, people who are late who can watch it later for the beginning part. Okay, I will start. Hi, everyone. Welcome to the TRIPS talk. Today's topic, as you see, is about the reasoning capability of large language models, which is something have been debated for a while. On one hand, we can see there's already a lot of work as summarized by this recent surveys on large language models reasoning capability. So for this researchers, I think large language model can do reasoning is already a fact. It is not something to be discussed. But on the other hand, we also have researchers recently challenged this claim, showing that large language model, at least on some key problems, doesn't really do well in reasoning at all. They even say that this models does not have reasoning capability. To me, the complexity of this discussion is both sides actually have solid evidence support or against this claim that large language model can reason. But the tricky part is the success cases very often if you make some small change or become a failure. And that's what some of the researchers have pointed out. On the other hand, the failures are not really permanent failure because very often the next version will fix it. Okay, so given the situation, I would rather not discuss any of the concrete case of success and failure. Instead, I will try to analyze this more fundamental problem. Is there any fundamental reason to say that large language model can or cannot do reasoning? Okay. So we start, of course, from the basic concept of reasoning in a very broad sense. I think everyone agree. So by reasoning, we mean to derive new knowledge from given knowledge or existing knowledge step by step. And there has been a lot of study on this topic, mostly in two domains, logic and psychology. But they are actually focused on different, or they're studying different models. Uh, in in logic, what they're talking about a normative model, or that is what is valid reasoning or correct reasoning. Okay. So this we know that start from Aristotle's logic system and developed into mathematical logic. And especially for researchers in mathematical logic, they deliberately try to keep some distance from psychology because they think human reasoning are not always valid. Okay. So on the other side, psychologists, they develop their own model. Part of the reason is the same, is human reasoning. Human thinking does not follow logic, as shown by the well-known examples like Wilson selection task and so on. In AI, the people who start to study reasoning initially start the so-called symbolic AI approach, which mostly follow the logic tradition. They study what is the correct reasoning rule and they build it into the system. Either follow classical logic or some version of non-classical logic, which try to modify the traditional logic to make it closer to actual human thinking practice. But there are still normative models. Okay, so that's start about what is the valid or right way to do reasoning. So large language model is a very different thing in this context. So we all know that what large language model does in general is to try to summarize or recognize statistical patterns in human data, especially human linguistic behavior data. So in this sense, we can see that they're actually closer to the descriptive tradition Instead of judging what is right or what is wrong, they basically say, "Oh, that's basically what beings are doing, and we want to build a system to do the same thing." So you'll see that we have all heard the claim that for AGI, you only need to predict the next token, and everything else will follow as emergent behavior. Here, we include reasoning. Okay. So what really happens if you analyze the process? You'll see that artificial neural network, including large language model, they actually learn uh, various types of cognitive tasks, which include reasoning, okay, as what is end-to-end mapping. Okay. We know that artificial neural network is kind of like a universal function approximator. Okay. If you give it enough training data, it will approximate any input-output mapping or function. So we can see reasoning as well as many other cognitive processes as far as you can explain in language, then that can be learned by large language model and which will do similar things. Okay. So this is especially true in this recent development in large language model because they use new technology to add intermediate steps in the process. Okay. So the so-called reasoning model among large language model, they give you intermediate step, use technology like a chain of thought, and also some people use reinforcement learning or some form of search to provide those things. So which make it looks closer to what we call reasoning in everyday sense. Okay. So it's more like step by step. But there's still some fundamental difference. That's what I want to discuss today. So intuitively speaking, this is what traditional logic reasoning looks like. It's a step by step. Each step, it typically take two premise and derive a conclusion. Then the conclusion become the premise of the next step with some additional background, knowledge and whatever ever. And step by step, they reach a conclusion for for this inference process. Okay, so an inference process including multiple inference steps, and each step follow a rule in a given logic system. Okay. So you'll see end-to-end mapping or learning is very different. They kind of like directly jump from the initial input to the final output. Okay. So large language model, if you have many such reasoning process, then they can use this to train a model which directly give you the mapping. And not only the one that you provided it will be remembered, also similar ones will be handled because of given the ability for large language model or artificial neural network to generalize from the training data. Okay. So what is new in the step-by-step process like a chain of thought is they add more intermediate steps. Okay. So which will make it closer to the traditional reasoning process because the step becomes smaller and smaller. But if you check it carefully, you will see that it's still a mapping. Okay. But it's just a relatively shorter distance mapping compared to directly jump from the initial input to the final output. So it's still quite different, and the step is still much larger than what is taken to be an inference step in the traditional logical system. And not only that, uh, but also, oh, sorry, I don't see the slides.
Yes, we can see your slides, Pei. Um, I'm not sure why you're not seeing that, Antonio.
I don't see any slide at the moment. Don't
Um,
know why.
Maybe your view
Maybe
settings.
my
Uh,
view.
are you the only one?
Maybe I'm the only one. Sorry. So it's my fault, maybe. Because I don't see any slide.
Okay, I'm sorry,
Okay.
but
No,
later,
no, sorry.
yeah, later I will distribute the slides. So you, yeah, you
Okay,
can.
thank you. I will see. I will try to fix it anyway.
So go back. So we still don't have really have the inference step is defined not only in logic, even in psychology, in traditional psychology study of reasoning. Uh, the inference step studied there is not a step you can see in large language model. Okay. Uh, so that leads to the next question. I think this is the key technical topic I want to address in today's data. So in these two type of reasoning models, both talk about inference rules, but actually speaking, they're talking about different things. Uh, that kind of ambiguity actually exists in AI for many years already. That is, what is a rule? There's two different reading or different understanding. One is to understand it as a derivation according to traditional logic terminology. You have premise, you get conclusion. Okay. And the inference rule will carry out that process. Another sense is implication statement. Okay. That's also very often called a rule in the context of AI. So are these two related? Of course, they're closely related. Okay. Uh, the intuitive meaning, both of them, is typically explained or described as if then. Okay. If P is true and P implies Q, then Q is true. So also in logic, there is a deduction theorem, which say that for every valid inference rule, you can create a true implication statement, which take the premise as a condition and take the conclusion as the consequence. Okay. They're closely related to each other, but at the same time, they are different. Okay. Derivation typically is talking about a procedural piece of knowledge or is a small program, which is typically built into the system at the meta level. It's formal in the sense that a use symbol is content independent, okay, and also is automatically triggered in the system. On the other hand, implication is a sentence. You can learn it, you can store it in your memory, you can modify it by the system itself. So it's at the object level in terms of in the linguistic distinction. Okay, and also is content sensitive. It's empirical with empirical content. It typically need to be deliberately applied to a given situation. So does it matter? Do we really need to make this kind of detailed distinction? Actually, at least in the logic community, this difference is actually well established, and some of you probably know this. It's a very interesting reading. Okay, so this is also I learned it from Gödel Eschbach of Hofstadter. He said this is a dialogue, which you know that actually is a short story written by Lewis Carroll, who read Alice Adventure in the Wonderland. Uh, you see, many years ago. So basically, this story tells you that if you interpret a derivation rule as an implication, you cannot really derive any conclusion. Okay, so so this is well known. But on the other hand, in today's literature, okay, this is actually one of the survey I cited before. You'll see they deliberately take an inference rule as an implication statement. Okay. And I'm not really only criticizing this article. Actually, this is the case for all this literature, even though most of the authors doesn't even bother to spell it out. And they didn't realize this is conceptually wrong. Okay. So this difference actually explains to me a lot of things about both the strengths and weakness of large language model in the context of reasoning. The strengths we already know. Okay, it makes things much simpler, much easier, very efficient, and produce a lot of similar behaviors as human reasoning. But on the other hand, we also already know the trouble. Okay, many of the conclusion is not always valid. It's not reliable. Sometimes it works, sometimes it doesn't. Sometimes, very often, it cannot be justified or explained. And we know those issues. Why? Exactly because of the inference rules they're using. Okay? Uh, so can we teach inference rule to larger language model? Of course we can. Okay, you can teach any inference rule of any logic to larger language model by saying that if this is the input, then this should be the output and will be remembered by the model. But the problem is, all those rules will still be handled as implication statements by the system. Okay, so the previous difference will still be there, and which will lead to the weakness. So why large language model or artificial neural network in general cannot really learn inference rules in the sense of as a meta-level procedure? Well, there are actually several reasons. I think we don't have the time to go into the detail. Some of them are technical, some of them are conceptual. So the conclusion is they cannot. They just cannot do that. So this is the conclusion I gave in today's talk to summarize the whole argument. That is, large language model can solve many reasoning problems, but they're not using the reasoning mechanism. If we use reasoning mechanism in a sense that's already established in psychology and logic for hundreds of years. Okay. Or in other words, they are changing the meaning of reasoning. That is, if you judge behavior, is similar to what we call reasoning, but if you check the mechanism, is not. Many people will argue that it doesn't really matter. We just find a new way to do reasoning. Okay. I said, yeah, you can say that, but you need to realize that this new way and this old way have some fundamental difference, which cannot be overcome by additional training data or more powerful hardware or any of those. Okay. Does it matter? Well, to many users, it doesn't really matter. They just care about input-output relationship. Okay. But for the researchers, they should understand the fundamental difference is still there. So which will raise a lot of interesting theoretical issues, which we don't have the time to go into detail today, but I want to raise them. So clearly, many people will ask, okay, so basically it seems I have claimed that logic cannot be learned. And that sounds clearly wrong because, is logic acquired or innate? I said, again, here, we have two senses of logic. Okay? In a technical sense, when we're talking about a logic, we're talking about logic system or logic model with well-defined language, semantics, inference rules, all those kind of things. And this type of logic are clearly learned for us. Okay, we actually learn it at a much later stage. That's an argument many people have actually against our research in ours, say that logic come after sensory motor, right? You should start from sensory motor. Logic come at a much later time in human cognition. But in a sense, that's true. Okay? But there's a more general, broader sense of logic. Here we are talking about the regularity um, of thinking or reasoning or argumenting or whatever you call it. Okay. In that sense, logic is innate, or that type of logic is innate. You cannot learn it because of the reason I mentioned. But if it's innate, where it come from for a reasoning system? Again, here we need to distinguish two types of situation. For artificial system, according to this usage of logic or inference rule, they need to be designed and built into the system. And in natural system like human, of course, I'm not saying that there is an intelligent design. I say this come from evolution. And evolution is different from learning in the context of this discussion. Can you build artificial evolutionary computation system to learn logic? In principle, yes, we can, but that takes too long. That's not the topic I'm discussing here. So this again go back to the old topic in many fields, that is nature versus nurture. Especially in the context of AGI research. I think every AGI researcher face this problem. When you design or creating an AGI, what should you build into the system? And what should be left for the system to learn by itself? We all understand that the two extreme position clearly is not going to work. You cannot really build everything into the system. And also you cannot leave everything to learning. Okay. So the difference is in the choice. So the current machine learning, including large language model, they think inference capability is learned. What they build in are some kind of general purpose generalization mechanism, which can approximate arbitrary function, as I mentioned. But for people like me and some of you, we choose to build in the inference rules. Okay. So now we can see the difference between at least our model, NARS, with large language model. So here, the major difference, of course, start from our different understanding of intelligence. And also, given our intelligence is adaptation under the assumption of insufficient knowledge and resource, we choose to use a knowledge-centered, a concept-centered knowledge representation. And by the way, I recently finished an article on this topic with Chris, which will be hopefully published very soon. Okay, on this concept-centered representation, where concept summarize the system's experience. Then, according to this opinion, reasoning is not from truth to truth. Instead, reasoning is about to use one concept as another, so that you can use past experience to handle novel situation. Then the inference rules of our non-axiomatic logic are all built in at the meta level. But on the other hand, all the beliefs of the system, including the implications, are learned from the system's experience. And finally, the consequence is the system, like NARS, the behavior will depend on its own experience, not necessarily the same as human experience. That's another difference between our model with large language model. Okay. But then there are also some similarities, especially in recent development of large language models. Some people say, oh, you should not predict the next token, you should predict the next concept. And also the process should be driven by your goal instead of just try to predict what a human will say. That makes them kind of similar to what we are doing, but the details are still very, very different. And finally, some relevant work of our team. One is we're extending the NARS model, especially we're trying to finish the top layer of non-axiomatic logic implementation, which is about self-monitoring and self-control. One concrete task actually is directly related to what I said here, is we want the system to be able to kind of like also jump like a large language model. Instead of doing things always step by step, it should be able to summarize a derivation process, like from one task and believe to derive a new task into an implication that directly kind of like go from one task to another. And this derivation clearly can be chained together. So if T1 implies T2, T2 implies T3, then T1 will implies T3. So gradually, the system also will learn to make jump from the beginning to the end. They'll greatly simplify the process of reasoning and improve efficiency. So that will make it kind of like similar to large language model, but it's kind of like the other way around. Large language models start from end-to-end mapping and try to add intermediate steps. But our model actually starts from the step-by-step process and try to summarize it into longer jump from a beginning assumption or a premise to a final conclusion without having to go through every step in the middle. If there is enough training or experience to support this kind of jump. And finally, there's still a possibility of use larger language model as tools in ours. One project started by Patrick several years ago is Nars GPT. And if you are interested, you can check for the details. And also, this is more recent work of our team, which we try to handle this so-called natural language inference task. This is studied in the using large language model at the current time, which basically try to judge the logical relation between two given sentence or paragraph in natural language. Okay, so that's what we are doing now, or part of what we are doing. Okay, I'm glad I actually finished it in 30 minutes. Now, questions and comments?
Can I ask a stupid question? So I read rigid flexibility years ago. Was now 9 in that, or is that new thinking?
In that book is still the logic is divided into 8 layers, and later I realized that the level 8 is too big. I'm splitting it into level 8 and level 9.
Ah,
So yeah, 9 is kind of like just to focus on self-control and mental operation, which actually can be classified into 8. This is more or less arbitrary. It's in some other place of this model.
well, it's where the
That is,
operations are the operations of the inference mechanism itself.
yes.
Yeah. And that seems to be something which the large language model people are nowhere near. I mean, so your presentation, you didn't mention reflection explicitly, but it's implicit. And I think that's the one thing which large language models are never going to do. And
Uh,
so,
I will not say that because they already claimed some large language model. They already claimed they can do reflexive thinking. In a sense, I cannot argue against them, as I said before. Whatever you can do, okay, as far as you can explain it in natural language, they will learn it. So clearly, in their training process data, there is some reflexive reasoning process. Then they learn that on similar problem, they already claim large language model can think about its own thinking process. They already claim that on some cases.
yeah, okay. Uh,
That's that's is this
It can imitate the language of what someone says when they're reflecting on their own thinking
exactly.
process.
Exactly. This is where this all those emergent ability come from. So whatever you can do, as far as you can say it, they can also do it. So this is also why they think this is AGI, because this is the general purpose mechanism to do whatever you said you can do.
Okay. Well, I don't want to preach to the choir here. I'll let someone else speak. Thanks.
So thanks a lot, Pei. Very interesting. Um, so one thing that a question that is more and more common now for us who work with NARS is that people ask for things that NARS can do that not GPT can do, so to speak, if you look from the outside. So maybe my two questions are, is that also along the lines of your interests? And two, do you have any like ideas of any type of abilities that NARS can do that large language models can't do? Jeff mentioned reflection and those kind of things. But if we can also imagine things that we would think would be very, very hard, even for future large language models.
Yeah, I was also asked this question by many people, uh, which is indeed very difficult to answer for kind of similar reasons I replied to Jeff. That is, large language model indeed is general purpose in the sense that as soon as you talk about concrete behavior, uh, you see, when you say, can NARS solve a problem which cannot be solved by a large language model? My reaction, even though most people don't understand this reaction, is what's the type of problem you're talking about? Meaning that not the in the context application sense, in the sense that are you talking about object level or meta level? At the object level, no. Whatever you can do, large language model can copy it and generalize it a little bit, and not always very successful. But at the meta level, there are some very fundamental difference. For example, I don't think large language model can really handle a concept well. But usually the user cannot see that. You don't see meta level. All the meta level capability will have to be displayed by concrete object level behavior. Okay, so that's the why it's very difficult to explain, especially to people outside this research field. What's really the difference? But if you really talk about object level, then that's relatively easy.
Mm.
We can just say, again, large language model just still cannot handle insufficient knowledge and resource. We all know that wherever it run into trouble is they don't have they don't have enough training data, or they don't have enough training time. For example, real-time situation, they don't have the time to train the new data, and then they run into trouble. So I can still claim, something like NARS, even though which is far from finished. So we cannot really use concrete applications, even though we have some, to convince people that this is a better way. But at the meta level, to me, is quite clear that the problem is still adaptation and insufficient knowledge and resource.
Yeah, I think it's very clarifying what you said, that large language model can solve many reasoning problems, but without the reasoning mechanism.
They actually turn a reasoning problem into a mapping problem, just like they turn everything into a mapping problem. But the problem is some of the reasoning problem can be turned successfully into a mapping problem, but not all of them, especially the one that you don't have sufficient knowledge and resource. So inference rule, we use built-in inference rule, which sounds like old-fashioned. Okay, why don't learn it? Well, the problem is as soon as you say I learn inference rule, not only it's not really a rule, inference rule anymore, it's the implication statement. Even if we don't care about those words, it becomes data sensitive. It depends on what kind of training data you have. So it can be highly biased because of the bias in your data. And it cannot be justified in general because it cannot be applied to different situations. Okay. If you build them in, then what we are using, of course, is also learning, but in a much more general level. We logicians are learning from human history, okay? The human literature and human, I don't know, intellectual history, they summarize inference rules, not from any data set. But clearly you can say, well, that's from the human heritage or human culture as a data set. And they abstract some patterns which we think is valid in many situations, and we build them into the system. Is that learning? That's learning, but at a much general or abstract level. It's still not coming out of nowhere. Of course, we learn the inference rules, but as a community, not as an individual. We learn the inference rules of a concrete inference system or logic model, but that's a different level. We don't necessarily learn it well. We sometimes fail. And also, we don't always apply them properly. And we make mistakes, but that's a different story.
But if anything, it seems to me like NARS really distinguishes itself from large language models in its ability, of course, to learn from experience after it's born, so to speak. And if there could exist any tasks that we could imagine NARS can be trained to do, but not a large language model, I would imagine it really would require an extensive, so to speak, history before demonstrating it. And
Yes, the same thing is true for human.
uh-huh.
It's like you cannot solve much any problem at all as a baby, but the potential is there. So the potential is innate, it's built in, so that you know that you some animal can learn, but there is a very high there is a very restrictive. There is something that no matter how much material you have, you cannot teach an animal to do whatever a human can do. That difference is in nature, is in innate material, is not in the training process. But humans, they limit, in general have similar potential. So our performance difference actually come from our experience or our training. So in terms of application, if we really want to convince the general public, we have something that large language model don't have. To me, the currently the most promising part direction is still related to what Patrick have been doing, robot. We can easily find a robot application situation where the sensory motor mechanism is very different or completely different from that of a human being. So you cannot, even though now they're using large language model to control robot, but they still limited to a situation where human experience will still play a major role. Okay, if the sensory motor mechanism is completely different from that of human, you cannot use human experience to help at all. They're not using the same terminology. They're not using the same concept. So on the other hand, some people may say, oh, you can train the robot with its own data, but that will be very expensive to accumulate those data. And also, sometimes the robot will make a mistake, which will destroy itself. So it will be very expensive and even risky. So I think even though in principle the mechanism should be able to be applied to many situations, the most promising field, if you just want to make a difference, is the field where or the situation where insufficiency or knowledge and resource cannot be ignored. Large language model can ignore that because they already have a huge amount of data. And also, they separate the training process from the working process. So the time restriction in the training process will be omitted by many people at least. If you have to learn it right here, and then use it right here, they only have very limited ability to do that in their context window.
Any other like comments or thoughts on Pei's talk?
Maybe for method, I think also it seems that the biggest challenge for LLMs is still this ability to build new knowledge interactively, and there still doesn't seem to be a model which can actually cover that. And there's also the question to what degree this is linked to the very fundamentals according to which large language models are trained using backpropagation algorithms, using this idea of batches, and in training, where essentially you need the data set to be present beforehand. But on the other hand, there are some abilities to fine-tune a model after it has been trained, but but it but that's only good as long as the new behavior should not contradict too much what it already had in the training data. And so I guess what seems to be missing is also this ability to really adapt to new information in a way. And mhm. I wonder what you think, Pei, about whether it will be possible to extend LLMs in the future to handle like continual learning.
Oh, I think that's a fundamental issue they cannot solve, but they're moving in that direction to make it less and less obvious, at least in certain domains. So you
Mhm.
see they're making this window larger and larger. So the prompt and the recent history of conversation will be remembered and used, even though they can still use that to modify the parameters in the model itself. Okay, but to make many user more satisfied for a given conversation, at least you remember what I said in say 3 sentences before. So that makes things a little better. So I
Mhm.
think, yeah, yes, and also actually several people really are talking about the learning in during a working process. Even though I don't think they can completely solve the problem. They can solve some of the problem. For example, to hook up the search engine so that they can get more recent data into the conclusion. So I think almost all the issues, the concrete issues I mentioned in today's talk, uh, none of them are completely unknown to the large language model community. But what they think is they think they can fix it using some kind of patch or small revision of the model. But to
Mhm.
me, is much more fundamental. It go all the way back to artificial neural network, deep learning, and even the machine learning paradigm, where they think all problem solving can be treated as a function. So they just want to learn that function. What I have been saying is basically saying that intelligence is not a function in essence. It's not an input-output mapping you want to approximate. Or you can say, oh, it is an input-output relationship, but it's a one-time function. And so each time you use it, you're changing it. Okay, so that actually speaking, you cannot call it a function anymore because function is supposed to be accurately repeatable or yeah, in some sense repeatable. Otherwise, it's not even a function.
Mm-hmm.
Another thing is you see that if we have the time, we can go into a little bit more detail. Like for example, the issues I listed in this slide. So variable banding, right? I know Patrick, you spent quite some time to do that, and in something similar to a neural network. And this is an old problem. Started in the late 80s. You know, there's people discuss about how to do variable banding in artificial neural network. But so far, to me, most of the discussion is at the technical level. They try to find some operators which can be applied to vectors so that they can combine two, then they can go back. But to me, it's a more fundamental issue. It's related to the notion of symbol. You see, symbolic AI have been criticized exactly on that position because their symbol can be arbitrarily interpreted. So how do you know what is the right interpretation? That's the Chinese room argument. That's the symbol grounding problem. Okay. But actually, to me, this variable banding problem is the opposite. They claim that neural network solved this problem because they don't have arbitrary symbol waiting to be interpreted. But that just means that they also lost the ability to give a symbol different interpretation at a different context because they already bounded or grounded to some specific input material. Okay, you cannot say, okay, in this case for X, I mean this. In another case for X, I mean something completely different. So variable banding and symbol grounding demand two opposite mechanism. Well, can we have that? Yes, we can, because, for example, in ours, we have constant term, we have variable term. Constant term have a fixed interpretation in the sense that they always refers to the same concept. So there is no symbol grounding problem because it's already grounded, even though not in the external objects, but in the system's own experience. But to me, that's the right way to do it. Okay. On the other hand, we have variable term, which can be deliberately related to different things in different contexts. So that's kind of like ability to bind it to different interpretation, which I don't see there is, even though there's already a huge literature, all the solutions I see is typically applied to certain situation. I don't think they can have a general approach to handle this. And of course, that's something they don't want to do because they go back to symbolic AI. If you always demand interpretation to your symbols. Another thing I listed here is if you really want to learn, machine learning, some machine learning people have this belief that everything should be learned, including the inference rules. And actually, many people ask me why the NARS inference rule cannot be learned. Yeah, since they can, actually, people have do experiments, especially with large language model. Today's large language model, several of them, actually, you can ask them about the NARS, and some of them even know NARS inference rules. But you have to tell it. So if you're using Nernst inference rules, if I give you this premise, what is the conclusion? Okay, to a certain degree, they can do it. So they claim, oh, we can also learn Nernst.
Mhm.
But the problem about that kind of learning is, at least here, there are several issues. One issue is meta-level learning is not always something you want to do because it can be very dangerous. It can create some inconsistency within the system. And also, you'll see that this is also something discussed a lot in Gödel-Eschenbach by Hofstadter. That is, if you want to learn meta-level language, you need meta-level rule. Okay, they go back to an infinite regression. So you have to fix something in the system for it to work. Otherwise, you have to uh, introduce some completely arbitrary or random process, which can be very dangerous. It's not always nice to have. So that's a dilemma. Okay. Another thing is, even if it can learn NARS or many inference model, is not the one that they don't really necessarily know when to apply it. You have to say, oh, you use first order predicate couplers to do this. You use, say, Bayesian conditioning to do that. You use NARS to do this. Otherwise, how can the system decide if there are multiple models they have learned? Which one should be used? So in that sense, go back to my previous claim is there are two types of logic. One type is innate, one type is acquired. And it's my belief that you can only have one innate logic to be consistent, and you can have any number of acquired logic, which you learn. So NARS is an attempt to copy the innate logic of human, even though that sounds kind of like too ambitious a claim, but that's indeed the attempt. But it does not replace the other logic for special purpose tasks. You learn them, you use them, but you need to have something built in. And general purpose function approximator to me is not enough, even though it is enough for many applications.
Hmm. Mhm. I
Wow,
guess.
that was a lot of info. If I may jump in here a little bit, I'd like to go back um, to the reflection issue because I think you'll have infinite regression if you say, well, you have to have meta logic to talk about the logic, and then you have to have meta logic and so on. I think that seems to be a very inefficient and very non-biological way to do things, and I would be very surprised if nature did it this way. But of course, I could be wrong. I think nature probably figured it out, and I refer to nature because I like to take human intelligence as the gold standard to some extent. So that's sort of the background always for me, um, or comparison level of comparison. But in any case, I think nature probably figured out a different way of dealing with the meta. Because I know that you know that I know that you know, and I can do this about 4 or 5 times, and then I get rather confused, and I have to slow down. And the sixth time, somehow, the meaning disappears.
Yes.
And I really like, on a good day, I could get up to six. On a normal day like today, when I'm doing all sorts of things,
You can
it
get to
isn't
6 levels.
three.
I 3 level, I think to me is the maximum.
I know. Yes, but if you do it sort of, if you take aside 2 hours and you try this, you can sort of get up higher. Now, I don't think there's languages, logic languages in our minds to deal with the level below like this. Or rather, I think there is a circularity that the 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 mechanisms can to some extent turn on themselves. So some of the parts of their operations can become subjects of themselves. So you don't need you have one language, and that essentially deals with reasoning and meta reasoning. And I don't really think we need to talk about more than two levels, because I think every proper reasoning, every real reasoning, like, or general reasoning, has to include meta reasoning, uh, because otherwise, you couldn't. And that's possibly one of the things that separates us from other animals, or uh, maybe not completely from apes, etc. But at least they do not have it to the same extent. Now, otherwise, they would, in my theory, would have language, proper language. But in any case, that I think nature probably deals with this in a different way. It separates the ability to reprogram the higher levels somehow. So it's a connection to the goal drivenness or goal settingness, or let's say purposeful sort of pursuit of an outcome, that it separates it. And this is why it's hard for most people to take their own lives. It's that kind of, there's some mechanisms. The higher you go up, the harder it is to break them. But it's not about the modeling. You can model stuff. That's fine. But you just can't put it into action. And I think this is also the disconnect between the LLM folks and us, is that they don't see any distinction there. It's all just a pot that you just have to stir in. It's a pot of correlations. And no matter what you tell them, it's like, well, all we have is correlation. So forget about anything else. Um, well, that's what I wanted to throw in here. I could go on for longer, but I think someone else has probably a point they want to make. So,
if I may jump in here, because I really enjoyed this discussion. I think it's also an issue of what Pei said earlier about not being a function, but rather an ever-changing, even if you see it as a function, then every time it is called, it is an in itself manipulating function of itself. And I often think of this as, LLMs keeping a state. And I don't mean remembering what I said earlier, but rather this common issue of, playing guess a number game with the LLM. It doesn't work, right? If you tell an LLM to pick a number between 1 and 10, and then you try to guess it, it will not work, because there is no mental internal state of what number it has picked the first time, right? So whenever the new prompt is injected, it picks just a new number. And if different prompts are given, then this might lead to, the probability shift to leading, instead of picking 7, it this time picks 3 or something. And this keeping of an internal state that represents the mental, capacity of the system and its current goals and inputs and everything in an abstracted knowledge representation way. This is also very similar to the, I know, you know, I know, you know, I know, you know problem, or the meta-reasoning problem. It is this issue of having somewhere a state of what is actually right now happening, and then being able to reason over this state again, right? And producing, for example, assumptions that might lie in the future or that are induced by other rules, and using them as, truths for further reasoning. But in the end, it is this issue of keeping a state of current logic rules that have been interpreted in the last time steps, or the last, seconds. And it's the same issue with LLMs not being able to multitask, right? They just can't. They just have to always input the whole prompt to produce the next token. And there's no way of them keeping a state, doing something else in the meantime, and then coming back to what they were doing before. And it's always, in my opinion at least, I don't know how you guys, like, I'd love to get your input on this, but for me it always feels like this keeping of a mental state around is really important.
I think I fully agree, but I just want to mention I read that some large language model is trying to use some tools, external help, to keep state or to do things like that.
Yeah, but that's
Those
kind
are
of
those are going to
ridiculous.
be symbolic tools.
Yes, yes, they are.
Love it. Oh.
So just a comment, this task of understanding what I know that you know that I know and so on, I interpret that as something else, what you mean with null 9 pay. Um, I think null 9, my view of it is that it's, how to say it, self-control and, how to say it, being able to have goal-driven, so to speak, you can really affect your own thought process in that sense. Um, the I know you know I know sounds like a version of, how to say it, reasoning, which also is, yeah, and it sounds really like something we can also practice with experience, even if it's hard.
I will say these two topics are related, but as you said, Robert, they're not the same thing. In the terminology I'm using in NARS, at least when I talk about it in the book, I actually use two different terminology. One is what you just said, you think, I think, whatever. I call it a higher order statement. So it's a statement about a statement about a statement about a statement. And in this sense, this level or this layer can go to infinite in principle, but the complexity it introduced is typically what we cannot happen. That's we cannot handle. That's why in my comments to Chris, I said usually I cannot handle more than three. After that, you need to use pencil and paper. Okay, you need to keep track, who is whom. Like you need to have some kind of stack in your mind in terms of computer data structure terminology. But the other thing is what I call object level and the meta level. And that, at least in my system, there are only two levels. You don't have meta. Okay, meta level is NARS, is built in. Everything it learn, that's object level. That's something you can learn, you can modify, you can apply, you can forget. And the meta thing is fixed. It's in your DNA. You cannot learn it, you cannot modify it. Even if you don't like it, you cannot modify it yourself. Just like we cannot modify our DNA. The same thing in large language model, you can teach it NARS rules. Also, NARS itself in the future, probably you can teach it NARS rules and you can tell it that this is the rule that you follow. But it may say, oh, this truth value function sounds wrong because it does not agree with probability theory. Even if that happens, there is no way for the system to modify it. It's already built into its running process. So in that sense, I don't think there is meta. That also, as Chris said, I think nature already solved that problem. I think that's exactly what uh, Carl is talking about here. Okay, and you don't really, in human, you don't really have this infinite regression because at a certain level you directly apply the rule in your innate logic instead of thinking or challenging that. You don't think about, whether this is right or wrong, even if you have an opinion. You cannot change it. So to me, that's how, at least that's how it works in ours. That is, you don't go to meta, but you can go from first order, second order, third order statement. Even though typically you don't want to go too high because of the complexity.
Can I ask you a concrete example about how the meta level applies in relating to AI KR? I'm dealing with the French bureaucracy, right? I live in France, and I need them to respond to a request, and they haven't responded. So I lie in bed at night thinking about, should I call them? Should I write an email? Should I get someone to help me write an email? Should I revise the email? And after doing this for 2 hours, I realized that uh, I'm not going to get any farther. Just trying to create some other variation of a way to solve this problem. And so I have limited resources and I need to sleep. And so I stopped that line of reasoning. Where does that lie in your system of control theory?
This part, the NARS version, we don't really have it fully implemented, but that's the idea. It's a little bit similar to the so-called dual process mechanism. That is, there is an automatic process which is completely controlled by the built-in inference rule, and the control mechanism which is based on the idea of dynamic resource allocation or attention allocation.
Mhm.
So if we're using that mechanism, what you said is, you see the system, when you solve a problem, you have, for example, currently you realize there are three options, A, B, and C. You probably give it some initial evaluation according to your experience. You think, oh, it's more likely for, to solve the problem in A approach. But you think about it further, it seems going to nowhere. Then you're going to probably switch your attention to the B approach. Anyway, that this mechanism will work kind of like automatically allocate your resource, and you give up when you cannot go further because the confidence of the conclusion is too low. So you switch to another thing. But there is another kind of like more like level 9 approach. That is, you begin to accumulate experience about your own thinking process. You begin to know, for example, for this type of problem, I can solve it if I think hard enough and long enough. For that type of problem, I just don't have the background. I better give up even before I try. I will better to go to someone else, or simply give up because this is beyond my capability.
Mhm.
So this is more than what you can do use your automatic resource allocation mechanism.
Right, because there's some threshold of confidence, but that's built in. Can I change my threshold of confidence from point 3 to point 2? No. So yeah, that's why it's built in.
Now, even though we're thinking about, well, that's a separate topic, okay? Uh, Use evolution mechanism to have multiple versions of NARS, each with a different
Ah,
threshold parameter, let them compete in a certain environment. But that's beyond the individual level of
yeah.
learning. Yeah, that's why I clearly separate evolution and learning as two forms of adaptation, and both are adaptive, but they're very different. They can be combined together, but we are still a little bit far away from really doing large scale experiment on it.
Thank you.
There's one thing I'd like to throw in here, and then after that, let me urge the students here to jump on the question answer wagon. In talking about the levels of reasoning, I do I do like to keep cognitive development in the picture. Um, there are certain, let's say, mistakes that one could make if we ignore development as a mechanism, at the individual level, as part of learning, um, that you could end up with oversimplified ideas and ignoring some opportunities for how nature does this. And just a footnote, I'm not a big proponent of copying nature line by line at all, but it is definitely still a valuable source of inspiration, if not information. And so, but keeping so development, essentially cognitive development, means that there either are hidden codes that wait to be implemented and that willfully restrict what is possible at any point in time for whatever reason, and or that there are essentially three types of language or control mechanisms that each have um, possibly their own logic. Now, um, of course, these are going to be some sort of subset, I'm guessing, of very general logics, because they have to be implemented. They have to be the what is possible to implement physically in some way. So there's that. Yeah. One example, if you don't know what I'm talking about, if I'm confusing you, there must be a reason that 5-year-olds cannot handle double negatives, but 7-year-olds can. I think there's probably a really interesting, profound reason for that. And my working hypothesis is that the mind is building up all sorts of mechanisms. So it's not just possibly not just training the reasoning mechanisms or the logic, and I mean that in a very general sense, but rather that it's actually also controlling what kind of logic is admissible.
Yeah, to me, that's a very, very difficult problem. I fully agree with you that we all take human mind as inspiration, but they cannot copy it. One concrete topic here is the development in human mind. There are two processes going on at the same time. One is biological, one is psychological. Clearly, we only want to learn the psychological part. We don't want to learn, or we cannot really learn the biological part, even though, yeah, simulation, but I don't believe in it. So there's something we know is psychological. For example, say learning mathematics. You typically you learn addition before you learn multiplication because multiplication is built on addition. So you can say that that's more psychological. So we will expect AI to do the same. But there's clearly something is biological. It's related to that the human brain is there is a process they need to become mature. So for AI, actually, at least this is my position, we always try to start with uh, something provided by a mature brain, instead of, try to even take the growing process of a neural network into consideration in the simulation, even though it can be valuable for neuroscience, but for AI, I don't think we can do that. But it's very difficult to clearly separate which is also, my last question in this line. So that is what we want to build in, what is left for learning. And for me, some of them is very clear. Basic inference rule should be built in. More complicated inference rule, domain-specific rules need to be learned. For example, say Bayesian theorem clearly is not something I want to build in. I want the system to learn it. But the basic ability to do, for example, what we call temporal induction. Okay, that's something you need to build into the system rather than leave for learning. So then, if we really have the time, we can really go through the detailed functionalities studied in psychology. We try to say this is mostly psychological, so we should learn. This is basically biological. We need to build in. I don't have all the answers. It's especially, for example, uh, my work has been greatly influenced by Piaget's uh, theory in psychology, but I do not try to copy his idea about four stage of development because to me that there are too much biological factors in it. Even though in spirit, I agree. For example, abstract thinking need to be learned. We start from concrete sensory motor level of reasoning. Right? That in that sense, I agree.
No, I was just wondering about, if I may, a point that you haven't touched only slightly, which is the problem of the management of uncertainty, in the sense that in large language model, there is no explicit way to manage uncertainty because it is implicit in the token, in the essentially in the probabilistic prediction over token that reflect the correlation learned from data sets and so on. But there is no explicit way to how to manage uncertainty, which is a main a point in instead in reasoning. So because we reason on our reasoning is constrained by uncertainty. So I think that instead the NARS the NARS system, this is a strange this is a strong point with respect to large language models. So the capability to explicitly manage the role of uncertainty. So I think that this is one of the main points in NARS with respect to large language models. But this is just a comment.
Yeah, I completely agree. That's actually a central message I and Chris try to make in this paper on concept-centered knowledge representation. Large language model in this context I still don't think they don't have the right concept model. Everyone agree concept is crucial in cognition. But what they basically do is turn everything into vector and say, a concept that is implicitly in vector. But as Antonio just said, for something you need to be more explicit. But as soon as you do that, they will say, "Oh, this is old-fashioned symbol. You don't have grounding, and so on. All the other troubles. They still don't get, what is a concept, what is a symbol, what is a variable, and all those things, they kind of like all mix it together, then they throw it away. But in what sense a vector is not a symbol?
What are your definitions then, or the difference between concept and symbol?
Symbol, in the very general sense, is something you use to represent something else. As soon as you have that, you have a symbol. So a concept in that very broad sense is also a symbol. But the key difference is in the traditional symbolic AI tradition, when you talk about a symbol, you talk about a name you gave to an external object or event. Then you manipulate your internal representation, you try to say that correspond to something in outside. But this inside-outside relationship is missing in your model. So that's the symbol grounding problem. So how do you know what you are talking about? Concept, as far as in our discussion, is a symbol, but it does not represent an object. Instead, it represents your own experience. So it's already grounded in your own experience. Even though when you communicate it with other people, you may run into trouble like miscommunication, misunderstanding, because we use the same name or same word for different thing. But in your own mind, uh, concept in a sense that empirical concept at least is already grounded. Even though it may have an internal ID in your model, that's not a symbol in the sense of the symbolic AI versus connectionless AI debate.
I love that because this fits perfectly with my own thinking in a way. I just find it interesting, generally speaking, that you talk about, grounded in your own experience, which I like. I get what you mean by this, and I understand how this makes sense. But especially in this particular case, I find it very interesting because for me, a symbol is the internal representation of an external stimuli, right? So I have something that I can in some way measure or get into, the cognitive system, and that kind of triggers particular rules or particular models or particular knowledge representation parts that correspond to this stimuli, and that is now the symbol that is derived from the stimuli. Whereas a concept is for me the unbound, right? So it is grounded in experience because there are some parts of the knowledge or some, knowledge representations in there that have been built through experience, but they are unbound to any external stimuli, right? So they do not necessarily have to have a value assigned to it. Like the concept of a car does not have to have a color, right? It's just because this is unbound. It is not in relation to an external stimuli. It is only in relation to own knowledge representations that have been learned. Does this fit with your grounding idea of experience grounded?
Uh, In general, it is, but I will use the word differently. So, for example, in your example, I will say that I do have a concept of car, even though this car concept does not associate with any specific color. It is grounded in the sense that this one also have some other properties come from my experience. It's not just it's not just like X or a Y. I can use it to refer to any arbitrary thing. Okay. Even though when I say, okay, this is a red car, and this will be a richer concept compared to car because it have additional properties. But I'm not going to say only when you have that, it's become grounded. It's or you can say ground is a matter of degree, so this is more grounded, and that's okay. So what I'm saying is, this car concept and this X and Y are very different. X and Y are symbols. A car, on the other hand, is a concrete concept or empirical contents already there, even though you can make it richer. Or we use natural language, so car is grounded, but the pronouns like it is not, because that's more like a variable or a symbol in this discussion. Okay, when I say this is good, this is bad, you don't know the meaning because it depends on what this refers to, right? So you say there is a symbol grounding problem. Uh, that's okay, yeah, in a sense. But a car is always grounded. in our common usage of this word. It just different people have different relations or different models in their mind wherever this word is used.
Love that. Thanks.
And easily gets confused. We can say, let X be my car. Yeah, but we have to be careful. You can always make a symbolic
Yeah.
link. Yeah.
That's also related to my previous discussion, saying that you can say that in this conversation, okay, X refers to my car. But in a different conversation, you can use X for something else. But typically, you do not want to use a car in this way. You say, okay, in another conversation, car really means Apple. That will confuse everybody, even though if you insist that you can use the word in that way. But that's very unnatural.
That's why most people on the planet hate math.
Exactly.
Um, when we talk about concepts, well, first of all, I don't think, Chloe, you have asked anything. Do you have anything you want to throw out here?
No, nothing in particular. No, it's just a very interesting conversation. It's kind of
Um,
cool to
you are working on a robot, and Patrick has probably the most experience with robots in this. Oh no,
mm,
excluding the professors, I guess. So we came across an issue the other day, Chloe, did we, with your robot.
mm.
Um, what was this thing? Was it related to creating a new concept, or am I mistaken?
Um, yeah, I'm trying to think. 'Cause yeah, let me see if I've got something in my notes. Because yeah, there was something really interesting.
Maybe that also something that will be covered in next trips talks that will be from
Hmm.
the Reykjavik team.
Possibly, yes. But the overlap here is interesting, and maybe we can throw in some thoughts on this. So this is also something that Jeff has thought about quite a lot, and that is, where new concepts come from. And I suppose I think we were maybe using or I was maybe using the term ideas, but I think it's
Mm,
actually more interesting to ask it using the term concept because, um, well, there is one way in which concepts appear or come about, and that is based on, you know, a concept is useful because now if you have a concept, you can give it a name and then, and pick a symbol for it. And then you have a very compact way of referring to it. So, um, the concept of a table or the concept of a chair probably came from experience, but there are concepts that don't come from experience. And so whatever concept mechanism is in a human mind, it must be somewhat it must go somewhat beyond experience, is I think, if I'm paraphrasing you, Jeff, correctly. Um,
Yeah, we don't experience electron shells, but we can think about them perfectly clearly.
yeah,
We don't experience nuclear winter. We all are still alive right now because scientists convinced governments that nuclear winter was a real thing, but that doesn't come from experience. That's why they didn't attempt to take out the other guy with nuclear weapons.
yep.
So the
So
time is
it's
officially
go
up,
ahead.
right? So the meeting is about to end, but maybe we can have one last comment.
Well, I suppose this could be a nice transition over to next month's topic.
So that's on May 6th. Will it be you, Chris, or someone else from
I
you?
don't know. We haven't negotiated how we're going to do it. We want to have it be entertaining. Number one, informative. Number two, and not confusing. Number three. So these are the parameters we're working with, and I could foresee maybe a three-part with well, the four of us that are here, maybe sort of dividing the work up a little bit, but let's see. Let's not make it too confusing and too fragmented. So um, around the middle of the month, we'll have, yeah, sometime after Easter, around the 22nd, 23rd, we'll have a description and forward to you, Robert, and you can send it around. And in the meantime, we can take requests. So anyone who wants to ask us for something in particular, we can either then take that on as the topic, or we can try to weave it in to the presentation.
So anyone interested can email you with like requests. Oh, great.
Yeah.
But to Pei, thanks a lot for this talk. Extremely interesting and extremely nice discussion.
Yeah.
Thanks a lot, Pei.
My pleasure. Just one last sentence. For those of you who haven't heard about it, the four team of us is planning to organize a full day workshop in AGI 25 in Reykjavik. So whoever have ideas, welcome to discuss. Then we will have more time to debate and to discuss topics.
Exactly. Okay, see you on May 6th then, everyone. Bye-bye.
Great. Bye.
Bye-bye. It was a pleasure.
Bye. Thanks.
Bye bye. Thank you very much.
Well, thank you.
Well,